This video is on trigonometric functions and right triangles. Theta is a Greek letter used to represent one of the acute angles in a right triangle. Because one angle is 90 degrees, the other two angles together will add up to 90 degrees, meaning they're both acute, or less than 90 apiece. The hypotenuse is a side opposite the right angle of your triangle. The opposite side is a side directly opposite angle theta, and the adjacent side is a side next to angle theta that is not the hypotenuse. So I'm just going to show you an example. So if we have angle theta, we know the hypotenuse is always opposite your 90-degree angle. The opposite side is the side directly opposite angle theta, and adjacent is the side next to angle theta that is not the hypotenuse. Okay. So here are some of the functions that you're going to need to know. So sine of theta is always opposite over hypotenuse, meaning you can find the angle measurement if you know the opposite and the lengths of the opposite and the hypotenuse, or you could find one of the side lengths if you know the angle measurement and one of the other side lengths. So these are very important. Cosine is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Cosecant, secant, and cotangent are all reciprocals of sine, cosine, and tangent. So cosecant theta is hypotenuse over opposite. So it's just sine flipped over. Secant theta is hypotenuse over adjacent, and cotangent of theta is adjacent over opposite. So we're going to use all of these to help us identify side lengths and angles. You can just stick to the first basic three, or you can use these ones also. So there's a little trick to remember these. It's called SOHCAHTOA. SOHCAHTOA. So sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Okay, so it's just a little trick. If you sound it out, you can figure out. I suggest every time you sound it out, write it down, and you can figure out the order that these go in. So you always know when you're dealing with sine, sine of theta equals opposite over hypotenuse. Okay, so one thing that you need to know is that to find an angle, you have to use the inverse. So if I know the two side lengths to find my angle theta, we would have to find the inverse. If we use sine, the inverse of sine. And I'll show you a few examples of that. All right, so this first one, we're going to find the measure of all sides and angles. So first thing I'm going to do is I'm going to find out the hypotenuse. Hypotenuse is always the side opposite my 90-degree angle. And I'm just going to abbreviate HYP. Okay. Opposite, the side opposite angle theta is the opposite side. And the side adjacent to angle theta that's not the hypotenuse, well, that's my adjacent side. I suggest you write it out. It makes it a lot easier if you have everything written out. So I need to find the measurement of both angles that I'm missing, and I need to find the side length. I'm going to suggest you use your calculator. On mine, I'm going to check the mode that it's in, and I need to make sure that it's in degrees. If it's in radians, change it over to degrees. And now I'm going to quit this. I'm going to press second, quit. Okay, now that it's in degrees, I can find the degree measurement of the angles. So I know my opposite and adjacent sides, meaning I'm going to use tangent. So tangent of angle theta is equal to Opposite over adjacent. So my opposite side has a length of 5. My adjacent side has a length of 11. So you can always go back and look at what it is to help you figure out which one to use, sine, cosine, or tangent. Because I knew opposite and adjacent, I knew I had to use tangent. So to find angle theta, for this I'm going to have to use inverse tangent. So it's tangent to the power of -1 of 5/11 will give me the measurement of my angle. All right, so I'm just going to simplify this. Okay, so in your calculator, on mine, my second function of tangent is the inverse tangent. So I'm going to press second tangent, so I get the inverse tangent. I'm just going to type in 5 divided by 11. I'm going to close my parentheses, and it gives me 24.4439. It keeps going. I'm just going to round out one number after the decimal place, so to the 10th spot, so 24.4. So that means my angle is equal to 24.4 degrees, and that is angle B. So I know that the measurement of angle B is equal to 24.4 degrees. I'm going to just start by finding all of the angle measurements. So this one's 90, meaning that angle C and B together add up to 90 degrees. So I'm just going to do 90 minus 24.4 to find the measurement of angle C. So I suggest you use the calculator for that. And I get 65.6 degrees. Okay, so I know all the angle measurements because I know this one's 90. I know two of the sides. I need to find the side length BC. I need to figure out what side length BC is equal to. So I do now know the measurement of this angle theta, so I'm just going to use that. I need to find the hypotenuse, and I can use either of my other sides. Okay, so for this one, I'm just going to use sine. So I know sine of angle theta, which, well, that's angle B, is 24.4 degrees, is equal to my opposite side, which is 5, over my hypotenuse. I'm just going to call this side x for right now. I want to find x. Okay, I want x by itself. Right now x is on the bottom, so it can be kind of tricky to solve for it. One thing that I can do is I can make this into a fraction by putting a 1 below it. And you can do something that's called fish math. This makes it really simple. All you're going to do is start above where your variable is. Here at 5, I'm going to multiply down diagonally, and then come up. I'm going to divide by what's on top, and it should equal x. Or you can just cross multiply and solve for x. But this is simple. So I start at 5, go down at a diagonal, multiply it times 1, divide it by what's on top, which is sine of 24.4 degrees, and that will equal x. Okay, so in my calculator, I'm just going to type in, I know 5 times 1 is just 5, divided by sine of 24.4, 24.4, it's in degrees, so I don't need to put the degree sign, gives me 12.1 if I round out one decimal place. So side length BC is equal to 12.1. Okay, and that's all I was looking for. So I have all 3 side lengths, all 3 angle measurements. All right, so I'm going to try another one. This one, I know 7 is my hypotenuse because it's opposite the 90-degree angle. The side opposite angle theta is 4, so this is the opposite side, meaning AC is my adjacent side. All right, So I know hypotenuse and opposite, so I'm going to use sine. So sine of angle theta is equal to opposite, which is 4, over my hypotenuse, which is 7. Okay, but because I need to find theta, I need to find the inverse sine. So sine to the power of -1, or inverse sine of 4/7 will give me the measurement of angle theta. So again, I'm going to use my calculator. So inverse sine of 4 divided by 7 is 34.8. Okay, and so that is angle C. So the measurement of angle C is equal to 34.8 degrees. Okay, to find the measurement of angle B, all I have to do is 90 degrees minus 34.8, because these two together add up to 90, because 90 plus 90 would be 180, and the three angles of a triangle add up to 180. So when I do 90 minus angle C, I get 55.2. Let's see. Okay, and degrees, can't forget that. All right, other thing I need to find is side AC. All right, for that one, I now know the measurement of angle theta, so I'm going to use that, and I need to use my adjacent side. I'm just going to call it x, because that's what I'm looking for. It's easier to call it a variable. So I'm going to choose that as x, and I'm going to also use the hypotenuse. You could use the opposite side, but I'm just going to use the hypotenuse, meaning when I'm using adjacent and hypotenuse, I use the cosine. So I'm going to use a cosine of angle theta, which is 34.8 degrees, is equal to, okay, cosine is adjacent, which is x, over hypotenuse, which is 7. Okay, this one's easy to solve for x. I have to get rid of the divided by 7 by multiplying both sides times 7. 7 divided by 7 is 1. So all I have to do in my calculator is 7 times the cosine of 34.8. And that gives me 5.7 if I round. Meaning side AC has a length of 5.7. All right, so those ones were pretty easy. I'm now going to do one where I have to find two side lengths, and you have to find one angle measurement. So, well, the angle measurement part is the easiest. So let's start with that. All right. So here, I know this one's 90, this one's 52 degrees, so angles B and C together add up to 90 degrees. So to find the measurement of angle B, all I'm going to do is 90 minus 52, which is 38 degrees. Okay, but now I need to find sides AB and also side AC. Okay, so to do that, I'm going to start, I'm just going to call this 52 degrees my angle theta. So that's what I'm going to use. I'm going to find side X. So I know this is my hypotenuse, opposite 90-degree angle. X would be opposite because it's opposite the angle theta, meaning AC would be the adjacent side. So I'm going to use opposite and hypotenuse, meaning I need to use sine. Sine of angle theta, which is 52 degrees, is equal to opposite, which is x, over hypotenuse, which is 9. To get x by itself, I'm going to multiply both sides times 9. And x, if I use my calculator, I'm going to do 9 times the sine of 52 degrees is 7.1. So that is side AB, is 7.1. Okay, I need to find my other side, my adjacent side. I'm going to call this side Y, just so I don't get my two sides mixed up. All right, so I'm just going to use the hypotenuse since I knew that, and I'm going to use adjacent. So if I'm using hypotenuse and adjacent, I have to use cosine. So cosine of my angle theta, which is 52 degrees, is equal to the adjacent, which I'm saying is length y, just calling it my variable, over the hypotenuse is 9. I'm going to multiply both sides by 9 to get y by itself. And when I type this into my calculator, 9 times cosine of 52 degrees, I get 5.5. And that is side length AC, so 5.5. All right, I'm going to have you try 3 problems just like those. And here's 2 of them. When you're ready, I'll move it down so you can pause it here. Here's the third one. I'm going to go through the answers with you as soon as you're ready. All right, so the first one. Okay, we have the adjacent side, the hypotenuse, and the opposite. Okay, I'm going to say sine of theta is equal to 9 over 15, or opposite over hypotenuse. So I have to find the inverse sine of 9/15 is 36.9 degrees. So that means that angle C, measurement of angle C, is equal to 36.9 degrees. Hopefully you did 90 minus 36.9 to get the measurement of angle B, which is 53.1 degrees. All right, to find side length AC, okay, I'm going to use what I know. I'm going to say the sine of, cosine, I'm going to switch that. The cosine of 36.9 degrees is equal to x over 15. Because I need to find my adjacent side, and I'm using my hypotenuse. So I'm going to multiply both sides times 15, and I get x is equal to, it rounds to 12. So side AC has a length of 12. Okay, so I did 15 times a cosine of 36.9 to get that one. All right, then on number 2, we have the hypotenuse, the opposite side, the adjacent side. Okay, so to find my angle measurement, I'm going to use tangent of theta equals 8 over 6, my opposite over adjacent. Okay, so I have to do inverse tangent of 8/6 gives me 53.1 degrees. And that is the measurement of angle B. So measure of angle B is equal to 53.1 degrees. I also have to find the measurement of angle C, and I just did 90 minus 53.1 gives you 36.9 degrees. All right, last step is to find the side length of BC. Just going to call that x. All right, so for this one, I decided to use sine. So sine of my angle theta, which is 53.1 degrees, is equal to 8 over x. I did opposite over hypotenuse. Okay, I'm going to put a 1 below this and do fish math. 8 times 1 divided by sine of 53.1 gives me a value of 10. Okay, so side length BC is equal to 10. And last one, we have the hypotenuse, opposite side, adjacent side. All right, so I'm given angles A and C so that I know the measurement of angle B is just 90 minus 66, which is 24 degrees. Okay, so I have to find side lengths AB and AC. Oh, I know AB. So AC and BC. All right, AC and BC. To find AC, I did tangent of 66 degrees is equal to 8 over x. Going to do 8 times 1 divided by tangent of 66 degrees equals x, and 8 times 1 over tangent 66 degrees gave me x equals 3.6. So I got AC equals 3.6. Then for BC, this one I did sine. Sine of 66 degrees is equal to 8 over, I'm going to call the hypotenuse y, so 8 over y, opposite over the hypotenuse. Again, I did 8 times 1 divided by sine of 66 degrees is equal to y, and when I did the math, I got 8.8 is what it rounded to. All right, hopefully you were able to get all the side and angle measurements.